It's unbelievable that humans can take over control. If you think about where this could go, this is really incredible. We're on our way now to the Nanjing Technical University to meet Dr. Sato, a researcher who's been working on some of the most advanced cyborg insects on Earth. Here. Hello?
Hi.
Dr. Sato?
Hi.
So what is the work that you do over here?
Our purpose to control the flight of the beetle. I studied many things about the kind of muscle configuration, neural network of this living beetle. And also I studied leg control.
This is also by stimulating the muscles?
Yes, leg muscles. And we can do some of the different walking gait motion.
You stimulate all the muscles individually?
Individually.
So the beetle actually has no control over what it's doing?
Yeah.
Then. So you basically make it into a robot, actually?
Like a robot. Of course some error, but that error is not so big problem.
I'd be very excited to see the work that you're doing right now.
Let's go to the lab.
Yeah? Great.
Yes.
Morning.
Oh, yeah, sorry. So could you tell us what you do here?
And we use this system to detect the leg motion, so we can put some marker on small marker on the leg.
And so this is the beetle that you're working with?
Yes. You can see the many wires, right? And my student at the Tao Feng, he is very good at the implantation and working on this leg motion control actually. And he knows about the location of the leg muscles very well.
Can you tell me a bit what you're going to do?
Basically, I will press there are two buttons. One can change the working gait. The other one is I can change the step frequency. That means how fast the leg moves.
Yeah. And these LED lights, they correspond each to a muscle?
Yes, so in total 8 muscles.
Yeah. Okay. Let's see.
So the step frequency is 0.125 Hertz. So it's tripod. So it's very slow now.
And so now it's alternating its left and right.
Yes, alternating. So if I want to increase the step frequency, I need to press this button. So that if I press once, so it's faster. Now it's 0.25 Hertz.
So amazing that you just press a button and the beetle starts walking.
Mm-hmm.
It's I don't know. It seems almost unreal. That you can kind of achieve this in a living creature.
If I press one more time, 0.5 Hertz, so it's faster. Then
this is really amazing.
1 Hertz. If I want to change to galloping, I press this button, so it will change to galloping. So yes, it's galloping.
And this is when it runs faster, basically.
Yeah, the step frequency is 1 Hertz. Now it's 2 Hertz.
Wow.
Yeah. It struggles itself, but it still obeys the stimulation signals.
And do you think, is he struggling to kind of stop these stimulation signals?
Yes, I think so. But still it obeys. You can see very clearly here.
And this just keeps on working like this?
Yes.
It doesn't get used to it or something? It doesn't...
No. I stimulate even like for more than half an hour, so it's still like this. We stimulate more than 7 days, more than 1 week.
And it keeps working?
Yes.
You're putting in electrical signals into the beetle now, but is it using up its own energy source, basically? Is it using the food that it eats to drive the muscles, or are the muscles driven by the electricity?
Yes, the food.
So you have to feed it to be able to keep on doing this?
Yes.
Looking at this thing, it's unbelievable, actually, that humans can, take over control over the willpower of this insect, because the muscles are being driven by the insect itself. I mean, it has to feed it has to eat to be able to move the muscles, and all that they are doing is putting a bit of electrical stimulation into the muscles, and they can control it to a degree that's amazing if you think about it. These may just be the first stages of this, but if you think about where this could go, this is really incredible. And how long would a beetle like this live?
The natural, regular beetles survive for 3 months to 6 months. Even after the implantation, beetle can survive for several months. We have never seen the beetle die right after the stimulation.
So it doesn't really hurt?
No.
So this is the walking part of the robot, and you're also working on the flight control. And you're also doing that here in the building?
Yeah, in this building, or the technical next building.
Okay.
Hello.
Hi, Alejandro.
I'm a student Leo, my student Tang.
Hello. Wow, this is a very impressive room.
We like a beetle to fly as long as possible. Then we use this smooth paper, and we release the beetle, and the flying beetle even crash on the wall. Still, the beetle go back to the arena to fly. Yeah. We make the air gap between the paper and the actual wall. Because the beetle crash on the wall, the beetle and our device does not be damaged.
Should I imagine it? Do you have a remote control or?
We use Wii remote.
A Wii remote. All right. All I gotta do is blow on its back to make its wings go, and then I can control it with this controller by pressing a button and moving it to a side. Yeah. Okay.
Press the right one. The right.
Hey, it worked. It went right. Can I try again? Als ik dan naar rechts druk, dan gaat hij naar rechts. En het werkt. You can also put other sensors on the chip, right?
Yes.
Because I can imagine that only steering a beetle doesn't do much yet for someone who's buried under rubble.
For rescue mission, the important thing is to locate missing live person, right? Live people. And live people is born, right? Therefore, by setting some sensor, we can detect some living people. And the beetle can move, walking or flying to the heat source of the living people and find the location.
That would be very useful. And do you see other applications as well?
Preliminary investigation will find some, the terrorist or something, We are very serious to use this type of beetle for peaceful application to save people and to save the world peacefully. Yeah.
I think the most fascinating thing that I've learned over these past few days is that technology and nature are creeping more and more together, and that we might be heading towards a future where technology and nature might become indistinguishable.